Hello everyone, let's solve Math Max Exam Math A, okay? 2015 question 2. So we are going to have a circle and it is circumscribed around a triangle ABC and its radius R. The angle, and he gave you the angle of this circle, okay? So this is the circle, okay? The circle is circumscribed around the triangle, okay? If it was inscribed, this is an inscribed circle, okay? But it is circumscribed, okay? So now look, I think you already read the question and you are trying to find the answer, something like this. Maybe you got stuck. Now the things that you are going to use in this question. Number one, you are going to use look, if you have, this is the center and you have like this angle over here, you can see that it is looking to what arc? It is looking to this red arc, right? So if we have another angle over here, something like this, you can see this angle over here and this angle over here, they both see the same arc, right? And they have a relation between these two angles, okay? It's called the inscribed angle theorem, okay? So if this is A, for example, this is 2A, okay? So this is the first idea that we are going to use. So if we have a circle, and we have something like this, okay? So this angle is 2 alpha if this is alpha, okay? Now what is the next idea that we are going to use? If this is the circle, this arc, the whole arc of the circumference of it, it's what? It is 2pr, right? The definition of p. And the radius would be, this is r, okay? So this circumference is 2pr, okay? And notice that the angle of the full circumference is 2p, okay? A full circumference. A full circumference. This is 2pr, the circumference, and the angle that it is doing, it's 2p. 2p is 30-60 degrees, right? 30-60 degrees, okay? So just this. Now, if you want just part of it, like let's say this is alpha, for example, okay? Now we just want this arc over here. If we want this arc over here, we are going to call it x, and x is to this alpha, okay? To the angle alpha. So we can do it, that rule that this is, we have a proportionality, okay? So this is the next rule that we are going to use. And the third rule is for the area of a triangle. If you have a triangle, for example, let's say here it is A, B, and this is an angle, theta, okay? So if you want to find the area of this triangle, you might call over here h, and you say that it is the height multiplied by the base divided by 2, right? So this is how we usually find the area. But what if you don't have the h? What if you don't have the height? How can you find the area without h? Well, you can have a relation. What relation? Look, sine of an angle is what? Is the opposite, which is h, divided by the hypotenuse, which is a. Now, one second. Where am I doing this sine over here? It is in this triangle over here. Let me take the red. In this triangle over here, okay? This red triangle. You can see this red triangle over here. So this is A, this is the angle, and this is H, okay? So, and sine of this angle is the opposite divided by the hypotenuse, okay? So, over here. So, H is equal to what? H is equal to A multiplied by sine of the angle theta. So in this rule over here, in place of h, I'm going to put this value over here, okay? So remember, h multiplied by the base divided by 2. But h is equal to this, so 1/2 of a sine of the angle multiplied by b, right? Because this is h. So just so that we make it organized, let's write b first and then sine of the angle, okay? So this is the last rule. Now there is another rule that there is one last rule that we are going to use to solve the question, which is for this last question. And now look, for this last question he said that he doesn't want you to use trigonometric function, and this, to be honest, I solved it using trigonometric functions, okay? I don't have any idea of how to solve it. Like, the only information that he gave us are the angles, so I don't know how we can find the length that he wants us to find without using trigonometry. Because if you use the sine law, the cosine law, you are automatically using trigonometry. So I'm going to use trigonometry. And what exactly trigonometry? One second. So let's take this off over here. Okay. So the trigonometry that we are going to use is just if we have a triangle, the cosine law, okay? The cosine law. If we have a triangle here and here is an angle, so this is A, let's call it, and this is B, for example, and this is C. So we have that C squared is equal to A squared plus B squared minus 2AB cosine of the angle between them. So notice that C is the opposite of the angle and AB are in the sides of it, okay? So this is the cosine law, okay? Something like this. So these are all the rules you need to solve this question. If you want, try to solve it now by yourself, okay? Pause the video and really try, okay? Go for it. These are the rules. So now let's solve the question. So now, solving the question after I showed the rules, I'm going to go faster, okay? So look, the arc length of AB and BC. So he basically wants this arc lengths. So we can use the first rule that we showed, right? If the relation of this angle over here, look, this is the arc. One second. Here and here. So this is the arc AB, okay? So notice that this angle over here he gave us. He said that it is C, right? Yeah, BCA, it's C. So this is 2C, okay? Remember the inscribed angle theorem? Something like this, I think. So this is 2C. And now we can use the second relation, the proportionality. Remember, the whole length of the circumference is 2PR. 2PR. Now we have a relation, the whole circumference divided by an angle to the whole, to make the full I forgot the name. So 2p, which is going through it all 30-60 degrees, is equal to what? To only this arc over here, which is AB, the arc AB, divided by the angle that needs to make the arc AB. What is the angle to make the whole circumference 2PR? It is 2p, right? And to make just the arc AB, it is the angle 2c, okay? So we have that AB is equal to what? 2CR, okay? So let's take this over here. Let's save it over here. So we have this. Now for the next answers, for the next ones, I'm going to do the same thing, okay? So look, now for the same thing again over here. Now let's use a red pencil. So let's say, for example, this over here, okay? So this is A, right? And this over here, what is it seeing? It is seeing this arc over here, right? And this also sees this arc. So this is 2a, okay? Now we have the same relation. What? 2pr, the whole circumference, divided by 2p, the angle that needs to make the whole circumference is what? It is BC, the arc that just the red arc, divided by the angle that needs to make this red arc. So we will have that the arc BC is equal to what? Now this is cutting, so 2AR, okay? So we have this next information over here. Okay, now for the last one, same thing that we did till now. Okay, so for the last one, let's use a green color. So 1 second here. So again the same thing. So this arc over here, this is the angle B, so this is 2B, right? So we have a proportionality, 2pr, which is the whole circumference of the whole circumference, divided by the angle of the 360 degrees. We have a proportionality between this and the arc that we want, the green arc, which is AC, divided by the angle 2b. So we have that AC is equal to 2br, okay? And this is our first answer for question 1, okay? So now for the second question. Now express the area. Now we are going to use the area rule, okay? If you forgot it, go back to the video and see the area rule, so that you can try to solve it by yourself. But remember, what was it? We can express the area by half of AB sine of the angle. For example, if we wanted the area of this triangle over here, which we actually want, so we'll have that this is the angle, for example, and this is a side maybe, so we can represent it by this. But in this way it is difficult because we don't know A and B over here, right? So what we are going to do is that we are going to use this information. We have the R, the radius. So what do I mean? Look, I'm going to divide this big triangle in 3 smaller triangles, okay? So this is the first triangle. Now remember, this angle over here, it is 2C, right? 2C, because over here is C, okay? So it is 2C, and this is R, and this is R. So we have exactly the formula to find the area of this triangle over here. How can we find it? 1/2 of A multiplied by B. So A multiplied by B, now in this case A and B are R, so it is R squared, because R multiplied by R, multiplied by sine of 2C, okay? So this is the area of the yellow triangle, okay? Let's just 1 second. We are going to have a yellow triangle, a red one, and an orange one. Okay, now just so that we know which one is what, this is going to be the red triangle, this is the yellow triangle, and I'm going to do the same thing for each of these triangles, and then I'm going to sum them together. Why? Because we want the area of the big triangle. So note, this is our first information, right? For the yellow triangle. For the next triangle, let's go to the red one. Now notice this angle over here, this angle, it is 2A, right? 2A, because over here it is A. Okay, remember from the first question we did this. So for the red triangle, let me take this mess off. Well, for this red triangle, this is A, this is 2A, and this is the radius, and this is the radius, right? So the area of this red triangle is 1/2 of R squared multiplied by sine of 2A, the formula that we just deduced, okay? 1/2 of sine of the angle multiplied by the 2 sides that he is between them, okay? If you want to remember it this way. What about the last triangle that we need to find? Over here. The one that was orange. This one. Over here it was B, and over here it is 2B, right? If you don't know this thing over here, it is just the inscribed angle theorem, okay? So, and this is R and this is R. So it is 1/2 of R squared sine of 2B, okay? So the area that we want is the total area, okay? The area that we want is summing this plus this plus this. So it would be 1/2 R squared sine. You can see that the 1/2 part and R squared part, we have it in all of them, right? When we are summing. And this is why he put it over here outside, because we can put it in evidence, right? Outside. So 1/2 R squared multiplied by sine of 2A plus sine of 2B plus sine of 2C, okay? So this would be this answer over here. So this is 2A, for example, to B, to C. You can change them, there's no problem. And R squared and divided by 2 is just multiplying over here. Notice that if you multiply inside, you'll get back over here, okay? You'll get this back, okay? So I'm going to delete all this now so that we can answer the last question. I'm going to delete this too, okay? So notice in the last question again, he is telling us without using trigonometric function, but I'm going to use one, okay? If anyone has a better idea, like, I really don't imagine solving it without trigonometry, okay? Because the only informations we had, like, he gave us the information about angles, so really weird. So look, we want the length of this sides, right? So over here, now remember, this is 2A, and let's call this x, okay? The side that we want is x. So BC, he wants calculate AB, BC, and CA. So let's call BC x, okay? And this is R and this is R, but now he gave us the value of R, okay? So R is 1. So he made our life easier. So 1 and 1. Now we can use the cosine law, to find x. So remember, x squared is equal to what? To the side R squared plus the other side R squared minus 2 multiplied by one side multiplied by the second side multiplied by cosine. One sec. Multiplied by cosine of the angle between them, which is 2A, okay? So x squared is equal to R squared is 1 plus R squared is 1. 1 squared is 1. So 1 plus 1 is 2 minus 2 multiplied by 1 multiplied by 1, it is 2 multiplied by cosine of 2A, okay? So now what is A? A is 75 degrees, so 2 multiplied by 75 is 140, 145. Let's do it over here just so that I don't make any silly mistakes. So 2 multiplied by 5 is 10. 2 multiplied 150. Okay, so 150 degrees. Cool. X squared is equal to 2 minus 2 cosine of 150 degrees, okay? Now, if you don't remember, the cosine of 150 degrees is just, if this is 30 degrees, here it's 150 degrees. You can do 118 and 80 minus 150, and you will get 30, right? Because the cosine of 150 is equal to the minus of the 30 degrees. Why the minus? Because it is in the minus side over here, okay? And why it is equal? Because you can see the shadow, okay? It goes, and then goes down. What is the cosine? You need to always remember, the cosine is the shadow of it, okay? So the cosine of 150 degrees is equal to minus cosine of 30, okay, degrees. So we are going to have that x squared is equal to 2 minus 2 multiplied by minus cosine of 30 degrees, okay? This is equal to cosine of 50 degrees, okay? Now, cosine of 30 degrees. Cosine of 30 degrees is square root of 3 divided by 2, right? And minus multiplied by a minus, we'll have plus, and multiplied by this 2 over here. And now we have this 2 over here. So x squared is equal to this, okay? So now we are going to have that x is equal to, this 2 will cancel with this 2, so square root of 2 plus square root of 3, okay? So this is our first answer. So now let's solve the other ones, okay? The other ones. So we already find BC. Let me call it BC over here. Over here it is BC, okay? So now let's find, let me use another color, the yellow one. Was it in the yellow? No, okay, it was in the orange. So notice that this is 2b, this is 1, and this is 1, right? Because the radius is 1, he told us. So now we are going to do the same exact thing, okay? The same exact thing, but now we are going to use another cosine, okay? So we are going to use that, we are going to call AC x now, okay? So x squared is equal to 1 squared plus 1 squared minus 2 multiplied by 1 multiplied by 1 multiplied by cosine of 2b, okay? So the same thing. So x squared is equal to 1 squared 2 minus 2. Now cosine of 2b, what is b? B is 60 degrees, so 120 degrees. Okay, now we need to find the cosine of 120. Well, the cosine of 120 is exactly the same as the cosine of 60 degrees. Okay, you can do the same thing if you don't remember this. Here, 60 degrees over here, it's exactly the cosine of 60 but minus, right? Because 120 is over here, so it has a negative cosine. It is in the second quadrant. So this is this is the cosine. So this is 60 and this is 120 and this is 180. So if you do 180 minus 120, you will get exactly the 60 degrees, okay? So it has the same cosine but negative, okay, because it is negative, it is over there in our quadrants, okay? So 120 has the same shadow, let's say, or something like this, okay? So we have that x squared is equal to 2 minus 2 multiplied by cosine of 120, so which is minus cosine of 60, okay? 60 degrees, okay? So cosine of 60 degrees is 1/2, okay? So we have that x squared is equal to 2. Now minus multiplied by this minus over here plus 2. Cosine of 60 is 1/2, okay? So this will cancel with this, and then we'll have 2 plus 1, which is 3. So we'll have that x is equal to square root of 3, okay? But what is x? It is AC, okay? So AC is equal to this. Now let's do the next one, the last one, okay? Like, if you didn't try already this last one, you need to do it by yourself, okay? This is the last one. It is exactly the same as we did for the last two, okay? So we have now, this is the angle over here, 2C. This is the angle. The angle is 2C. This is 1, 1. And this is now our x, okay? Our x is AB. So x squared, let's start to do it faster now. It is 1 squared plus 1 squared. So 2 minus 2 cosine of 2C, okay? So C now, C is 45. Now this is the easiest one because 2 multiplied by 45 is 90 degrees, right? Over here. C is 45. And now we are multiplying by 2. 2 multiplied by 45, it is 90 degrees, okay? So, and the cosine of 90 degrees, it's 0. So this term over here will be 0. So our x will be square root of 2, okay? So AB is equal to square root of 2, okay? So this is it.